In this video, I will build an intrusion detection system with logic gate ICs along with Arduino. Okay, so to build this project, we will need a breadboard, 2 NPN transistors, 2 10K resistors, 2 330 ohms resistors, an LED and some jumper wires. Okay, now we are going to build the OR gate. So first I'll connect the both of the transistors to the breadboard. Now I'm going to connect the collector pins of both the transistors together with a wire. Okay. Now I'm going to take the LED, connect the negative pin to the collector and over here. Now I'm going to take the 330 ohms resistor, connect it here to the pin of the LED and to the positive rail of the breadboard. Okay. Now I'll connect the both of the transistors emitter pin to negative rail of the breadboard. Connect this one to the negative rail of the breadboard and take another wire. Okay, we connect it here to the negative rail of the breadboard. Okay, now I'm going to use the 10K resistor connected to the middle pin of the transistor, the base pin, that connected here. Take the other 10K resistor and connect it like that. Now I'm going to connect this one to the positive rail of the breadboard. So these are the input pins which we are connecting now. Okay, so this is the circuit. Now let's power it up. I'll connect this to the negative for now. I'm using the Arduino Nano for power. I'll connect this to my power bank. Okay, using the orange wire for positive and gray one for negative. Okay, now see it's not glowing. If I put one of them, you see it's glowing, it's white. I'll take another LED instead. Okay. I'll switch off the light. So there are two inputs. I'll name this one as A and this one as B. I'll take the B, connect the B input to positive, so you see it's glowing as we have connected to the positive, connected to the negative, then it's it's not glowing. If I do the same thing for the A input, it will start glowing. If I connect it to negative, then it will not. Okay, so as you see it in the truth table, so if you see here the input A and B, and this is output. So if we give 0 means ground and ground to both of them, then the output will be negative. So as you see, I gave both of them ground in both of the inputs, so it's not glowing. Now if I give input to input A as ground and input B as positive, then it will glow. So this is input B connected, so you see it's glowing. Okay, connected back. Now if I give positive to input A and negative to input B, then it will start glowing again. Okay, and now if I give positive to both of the inputs A and B, then the output will be 1, means positive. The LED will start glowing, as you see here. Connected both of them to positive. Okay, okay, now we'll build the AND gate. Okay, so first I'll connect the transistors. Now we are going to connect the collector pin of one of the transistors to the emitter pin of the one of the transistors with a wire, like that, as you see here. Now I'm going to connect the collector pin of one of the transistor with an LED. I'll connect it here. Okay, now I'm going to take the 330 ohms resistor, connect it to the positive rail of the breadboard. Okay. Next, I'm going to connect the emitter pin of the transistor to the negative rail of the breadboard. Now I'm going to connect the base pin with 2 input pins. Before that, I have to connect the 10K resistor. Connect it to the base. Okay. Take the other one. Okay. Now I'll connect the input pins to negative rail and positive rail. Okay. Now I'll connect power. Okay, I'll connect this one to ground and this one to negative. Positive. Okay, I'll switch off the light. Okay. I'll take out the input pins and go and do it according to the truth table of the AND gate. Okay, so first you see input A has ground and input B has ground, so the output is ground. I'll connect it like that. Okay, so see that it's not glowing. Now the next one is if we give ground to input A and positive to input B, then also will not glow. Okay. Next is if we give positive to input A and negative to input B, then also will not glow. But if we give positive to both of the inputs A and B, then it will glow. Okay, so I checked a problem with the multimeter. There was less voltage coming to the base pin of the transistor, so I've replaced the resistor with a 1K resistor. Okay, these two. Okay, and there was also some loose connections which I fixed. Now we'll check the last row. Switch off this light. Okay, so we'll connect both of the pins, input pins, to positive, and it's glowing. Okay, since I have to use 2 NOT gates and 3 AND gates, I can't use transistors for this, so we are going to use the ICs. So now we'll build a circuit. Here's the circuit diagram. Okay, so I've already connected the DIP switch and both of the ICs. So the top IC is the NOT gate IC and the lower IC is the AND gate. Okay, now let's start building. First we'll connect the 1K ohm resistor to the positive rail of the breadboard. So it's negative. We'll do the same thing for the other 3 switches. Here. Okay, and the last switch okay. Now we'll connect a wire from the negative rail of the breadboard to the other side negative rail. Do the same thing for positive. Okay. Now I'll connect these wires from the switch to the positive rail of the breadboard. Okay. Connect another wire to the positive rail of the breadboard. Okay. So I've connected the red wires from the switch to the positive rail of the breadboard. Now we'll connect wires from switch 1 to the first pin of the AND gate. Connect it here. The first pin. Next, we'll connect the second pin to the 13th pin of the NOT gate IC. Next, we'll connect the third pin to the 11th pin of the NOT gate IC. Okay. And the fourth pin to the 12th pin of the AND gate. Okay. Now we'll connect a wire from the 12th pin of the NOT gate to the second pin of the AND gate. So we'll connect it here. The second pin. Okay. Next we'll connect a wire from the 10th pin of the NOT gate to the 13th pin of the AND gate. Okay. Next, we'll connect a wire from the 3rd pin of the AND gate to the 5th pin of the AND gate with this wire. Okay. And next, we'll connect 11 and 6 of the AND gate. 11. Okay. Next, we'll connect wire from the 4th pin, which is the final output. Now we'll get power for the IC. Connect wire from the 14th pin the positive rail of the breadboard of each IC. Okay, and next we'll connect the 7th pin of each IC to the negative rail of the breadboard. Okay, and the next one from here. Okay. Now I'll connect the transistor. So the flat side is the front side of the transistor. So this is the emitter. We'll connect a wire from the emitter pin to the negative rail of the breadboard. Next, we'll connect a wire, final output wire, from the base to the 4th pin of the AND gate IC, 4th pin. Next, we'll connect the LED. Connect the negative pin to the transistor's collector pin here, and we'll connect it here, the positive pin. Connect the resistor, which is 330 ohms. Okay, connect it here and connect it to the positive rail of the breadboard. Okay. Now I'll connect the power source. Now see it's not glowing. I'll change the code to 1001. Now see it's glowing. But if I give the wrong code, it will not glow. See it's not glowing. Okay? So that means that our model is working fine. Circuit is working fine. Okay, so now we'll build a circuit. To build the circuit, we will need the Arduino wire cable. Okay, we'll keep it aside. A buzzer, the Arduino Nano, a PIR sensor, a breadboard, and some jumper wires. Okay, so now we'll take the breadboard and the buzzer. We'll connect the positive pin of the buzzer to 14th and negative to 17. Okay, next I'll connect power from the Arduino board, 5 volts. On ground. I'll connect the negative pin to the negative rail of the breadboard and the orange wire to the positive rail of the breadboard. Okay. Now I'll connect a wire from the negative pin to the negative rail of the breadboard. We'll connect another wire, okay, which will connect it to negative rail. on another circuit. Connected here. Okay. Now we'll connect the positive to digital pin 2. Okay. Now we'll connect the PIR sensor. We'll connect the positive. Which one is positive? Connect over here. A yellow wire for signal and gray wire for negative. This is not. Take this wire and connect it directly to ground on the Arduino board. Connect this to ground. Okay. Connect the positive to the positive rail. I have replaced the wire of the positive pin of the PIR sensor. I've connected to the positive rail, and now I'll connect this wire to the digital pin number 3 on the Arduino board. Okay. So first we'll start by declaring some constants. We'll name the first constant as PIR sensor, and we have connected to 3, so we'll give 3. Okay. Copy this, paste it, and this to 2, and we'll name this one as buzzer pin. Okay. Now in the word setup, we'll write serial.begin 9600. Next, we're going to set the pin mode of PIR sensor to input and buzzer pin to high output. Okay. Next, we are going to set the buzzer pin to high. Low. Buzzer pin equals low. Okay. Now in the while loop, I'm going to give an if condition and check digital read if PIR sensor is equal to high. Okay. Then we'll switch on the buzzer. Copy this, paste it here, high, and if it's not, change it to low. Okay. So now I'll connect my Arduino wire. Okay, connected it. Just check if I've selected the right. Okay. Now I'll verify the code. I'll name this one as PIR sensor. I'll name it as burglar alert. Okay, done compiling, no errors. Upload it. Okay, serial monitor. I'll give digital read. I gave it like this. Okay, I'll now upload it. Okay. Okay. Now I'll get my hand. Okay, so that means it's working fine. Okay, so here's my treasure box. Okay, I'll show you the treasure box. Okay, it's okay. Give it back. And here's the circuit. I've disconnected the buzzer pin wire negative. I'll connect it. Now I'm wearing these gloves. I'll switch off the light and I'll connect the power. Because now see it's not producing any sound. So I'll make my hand come. Okay, now see it's producing the sound. Okay, now it's not. Again I will. Now it is again producing the sound, and now it is. Okay, so that means that the circuit is working fine. Now here is a problem. Even if I come, then also the buzzer will start producing the sound. So to fix that issue, we'll use a previous circuit where we have used ICs to build a secret code. Okay. Now we'll make some changes in our previous circuit, but before that I'll connect the negative from the buzzer. Both we have connected one to the negative rail of this breadboard and one will connect it here. Bring it close. Okay. Now we don't need the transistor. Okay, I'll remove it and we'll connect the LED's large pin to on this side and negative right here, and we'll shift this wire to negative rail. Okay. Now we will connect a wire from the final output to digital pin number 4 on the Arduino board. Okay. I'll declare an integer variable for values for of the PIR sensor. Name it as PIR sensor value and secret code value, which we have connected to pin 4. So I'll declare that, and constant secret code connected to 4. Okay, now I'll copy this. I'll set the input. I'll set it as input. Secret code. Now here I'm going to print the values. Just print ln, and here I'm going to assign values to PIR sensor value and secret code value from using the digital read function. Use digital read PIR sensor, and here we'll use digital read secret code. See, now I'm going to print the PIR sensor value and secret code value on the serial monitor. Copy that. And give PIR value secret. I'll make this capital. Okay, now over here I'll comment, I'll delete this and check if secret code value, if it's high, then I'll give low, or else high. Okay, now let's check it. I'll verify it. I'll remove the negative for now. Okay, now it should be here. Okay, it's producing the sound because we haven't yet given the secret code. I'll give the. Okay, now I see it's switched off. Okay, now I'll give the wrong one. Now it's again producing the sound. Switched it back on. Now we'll use the PIR sensor. So we'll give an if condition and check if PIR sensor is high and secret code value is low, then It'll execute this code. I'll cut these lines and paste it here. Okay. Now we'll verify the code. I'll just keep my PIR sensor there. I'll keep it somewhere here. Okay. Now I'll upload it. Okay, it's done uploading. Now I'll get my hands. Oh, I forgot to connect this. I forgot to give else. I'll use else. And I also forgot one more statement. This. Okay. We don't need this. So it's done uploading. So it's working. Now it is again, the buzzer is again okay, now it's coming, it's producing sound, now it's not, and now it is. Okay, so that means that our project is working fine. Here's the problem, that if the thief who is trying to steal something, if he doesn't move from that place, the PIR sensor will not detect anything, so the buzzer will not produce any sound, even if the secret code is wrong. So to fix that issue, we'll give an if condition and use only this part. We'll also use a flag variable burglar detected. Okay, and we'll assign it with 0. And give an if condition. If is equal to 0, I mean 1, then it will come in, or else it will be producing the sound even if the burglar doesn't come, and we'll change it to high. And right here we'll change it to 1. Okay, now I'll upload the code, check. Oh, I forgot to connect this wire. Okay, now test it. So it's producing sound. Now stopped. Now it's again producing sound because of the wrong secret code. Wrong. Now it should again produce. Now I'll get the right one. Okay. Now it's not producing any sound. Okay, so that means I'll switch it back off. Okay, now we'll test our circuit. I'll pretend these three guys as the thief, and here's my treasure box. Okay, now let's test the circuit. I'll connect my USB and voila. Okay, now he comes here. Now see that the buzzer is switched on, and they will think, oh no, the alarm has switched on. I'll run. Okay, then I'll come and check. I'll give the secret code and check if anyone stole anything, and there's nothing. Okay, so that means that our project is working fine. Thank you for watching this video, and I hope you found this video interesting.